Okay, welcome to guide sheet number 3. We're going to be looking at components, how to break a vector down into constituent parts. We want to do that because vectors are often not on the x or y axis. This gives us an opportunity to actually replace that vector with vectors that are on the x and y axis. So a couple of quick pieces of review. We're going to use CCW, that means counterclockwise notation. So 0 degrees to the right. We're going to come counterclockwise from that. East is 0, north is 90, west is 180 degrees, and south is 270 degrees. Okay, so about vector components. If a vector was directed at 120 CCW, that would be in quadrant number 2. That means that part of it would be going left or west, and part of it would be going north or up the page. We can figure out how much each way by using a couple of different methods. Now, in this first one, we're just going to sketch the general direction of the vector and determine what type of components and which component would have the larger magnitude. The first one is 45 kilometers at 300 degrees. So 300 degrees puts us in the fourth quadrant, a little bit above halfway. And then 45 kilometers, we're not measuring this to scale, so I'm just going to use that for 45 kilometers. Now, that means part of that particular vector goes east, and part of that particular vector goes south. Okay, now if I added the blue and the red, I would get the purple. So in terms of components, I have a eastward component and a southward component. Now 300 degrees, again, is more toward the south than toward the east, so it's going to be the southerly component is going to be larger. The break here in the middle is about 315. At 315, both of the red and the blue would be the same. Since it's closer to 270, that's more down than over. Okay, the next one, we're talking 10 kilometers at 265. Now 270 is straight down, so 265 is very close to that. That's going to make two components. Those two components are going to be a little bit to the west and a much larger significant part to the south. So the two components that we form there are west and south, and since it's very close to straight south, definitely the south is the greater of the two magnitudes. Okay, the next vector is 200 miles at 150 degrees. 150 degrees is something like that. Now, that's going to give us a vector that is westerly as part of the components, and a vector that is to the north. Okay, so the blue and the red are the components. So if we add them together, we would get the green. That means we have a west component and we have a north component. And in this case, the west component is larger. This is only 30 degrees. This is 60 degrees. It's much closer to 180, therefore it's much closer to being west. It's further west than it is north. Okay, in this case we have a grid to help us measure out the distances. Each grid, this is 10 kilometers of distance. So if we look at vector A here, it's going to have an east component and a north component. So east is the direction. Actually, I should put east second, so let's do that. That would be 0 degrees. And then the component for that one is 2 blocks, so it's 20 kilometers at 0 degrees. The north-south component would be from here up. That's also 2 blocks, so it's 20 kilometers at 90 degrees straight up north. B The southerly component would go from here down to here. That's the north-south, so that's 270 degrees, and it's 3 blocks long, so that's 30 kilometers. The west and east component would be west, so that's going to be 180 degrees, and it's 2 blocks long, so that's 20 kilometers. For C, its components go south and east. The east component is 0 degrees, and it's 1 block, so that's 10 kilometers at 0 degrees. And then the south component goes 20 kilometers, 2 blocks, and that's at 90 degrees. Now notice, since we're doing east, west, and north, south, all of these answers are going to be either 0 or 180. All of these answers are going to be 90 or 270 for the westward component, north and south components. D goes down and over, goes 2 blocks in each case. So that's 20 kilometers, and it's at 0 for the east-west and at 270 for the north-south. E goes down and over, so down is 20, and that's 270, and then west is 30, 3 blocks at 180. F goes down and over, gotta overstretch that one. It's down 2, so that's 20 kilometers north-south. It is south, so that's 270. And then it goes over 1, so that's 10 kilometers at 180. It's to the west. G goes down 2 blocks and over 2 blocks. Again, it is down, so that's going to be 20 kilometers at 270 degrees. And over to the east, so that's 0 degrees at and 20 kilometers, 2 blocks. Okay, so we've got, oops, I wrote that in the wrong spot. That's over here, 20 kilometers at 0 degrees for G, and 20 kilometers at 270 degrees for that one. Now, pause in a second, pause the video and try the last 3 for yourself. I'll put the answers up here, and you can see how you did. Okay, so H is 10 kilometers at 180 degrees. That's 10 to the west, and 30 kilometers south, so 30 at 270. I is 30 kilometers at 0, that's to the east, and 10 kilometers north, 90. And J is 20 kilometers at 180 degrees, that's to the west, and 10 kilometers north, which is 90. Right, so that's what we mean by components. And again, if we add the 2 components, the east, west, and north-south components together, we should come back to the original vector. Right, that's it for this installment. We'll look at some more components and using SOHCAHTOA to help us out next time.